Say you want to be an Android developer. What do you need? Well, everything is written in Java 6. So no lambdas, no streams, sort of an old, clunky language. You download the Java compiler. You download Android Studio, which is a specialized version of IntelliJ. Anybody use IntelliJ? Yeah, it's awesome. And you download hundreds of megabytes of libraries and crap. And you do all that once. And then you can start building your hello world. It's actually pretty nice. They've got this nice user interface. You can lay out your GUI. You can say, I want buttons, and I want this, and I want that. And actually, if we have time at the end, I've got it set up with one of my side projects. I can show you how it works in practice. They even have an emulator that runs Android on your PC. So an interesting difference between Android and iOS is that Android distributes its programs in an intermediate format. It's called DEX. All that matters is it's a bytecode that's not Java bytecode. It's a different bytecode. It's a register machine. But really, there's a compiler. And that compiler is available for ARM, Intel, and MIPS. And what that means is you can run Android apps natively on your x86 development machine at full speed. And so the emulator, you can install the ARM emulator, but don't do that. Instead, you install the x86 emulator, and you get to run at full blast. And it'll even use your native GPU. So Android apps will run significantly faster on your computer than they will on your phone, which is kind of nice. Anyway, that's the brief developer pitch. But let's talk about security. That's what we're here for, right? So fundamentally, exploitable bugs are a subset of bugs. So anything we can do to eliminate bugs will help us eliminate exploitable bugs. So how do you write bug-free code? Well, because Android apps are built in Java, they have all of the relatively nice security properties of Java versus C. There's no buffer overflows. There's no heap overflows. There's no use after free. There's no double free. There's all of these bugs that are endemic to the C programming language. And no Android app will have those bugs. They'll have other bugs. And it turns out most of the Android library and most of the system services are also built in Java. There's a lot of C stuff underneath, and you can add C stuff yourself if you want. They support the standard Java JNI, Java Native Interface. So you can write C code if you want, and many people do, mostly game people who are just trying to squeeze every inch of performance. But really, you don't need to. The performance of the Dalvik compiler is actually very good these days. You'd be surprised. So that's sort of the first level. You don't have buffer overflows to worry about. Yay. Android also uses process isolation. So many of you don't remember the bad old days when you had hundreds of people sharing a single Unix mainframe. When I was a college freshman at Berkeley in 1989, there were 350 students sharing a VAX 11750 with 8 megabytes of RAM. That's when Emacs stood for 8 megabytes and constantly swapping. Anyway, so the way to understand how you could have 350 people sharing one computer is that Unix is a multi-user operating system. And every user has a separate user name, and my files are owned by me and not you. And my home directory is not readable by you, so the operating system keeps you out of my directory. Unless I make it world readable or world writable and I can change the permission bits. Android does the same thing, except the users are apps. So now Facebook has a directory, and Google Plus has a directory, and Snapchat has each one of these has a separate directory with its own user ID, and it's actually derived from the digital signature on the app. So what that means is you can have the same good old-fashioned Unix multi-user security, except the users are now remote developers, which is a nice change from like the Windows world where everybody's administrator. So apps can actually isolate themselves from one another. Apps don't have root. And we're not depending on Java for isolation. We're depending on good old-fashioned Unix permissions for isolation. So if you can find an obscure Java bug that lets you break out of the type system, congratulations, but it won't help you attack another Java app because that other Java app is in another process. If you've ever worried about Java applet security, where you're running untrusted code and counting on Java as a sandboxing mechanism, that's not an issue in Android. The sandboxing comes from the operating system, not from the Java type system. So the Java type system is simply a feature to help you for having type errors. It's a bug thing. It's not a security thing, I guess. Anyway. Apps can request permissions. So there are all sorts of different kinds of permissions. Permission to access the internet, permission to access your calendar, permission to access the camera, the microphone, etc. And some of them are more interesting. If somebody wants to request the permission to be your SMS app, that's interesting. The user should hopefully say, well, maybe I don't want this game to be my SMS reader. I hope users would notice that. So what's the user experience around these permission requests? In older Android, everything before Android 6, the way it worked was that permission requests were in the manifest. So when you download an APK, that's this compiled zip file-like thing that has all of the contents, the very thing at the top is an XML file called a manifest, and it says, I need these permissions. Calendar, internet, SMS, whatever. And at that point, it asks the user, here's the list of permissions this app wants. Yes or no? And in fact, you could install from the web page, the Play Store or website, and it would ask you on the web server. And then if the user on the website said OK, it would push it all the way through and install it directly without anything showing up on your phone. That makes your spidey sense tingle. That might not be good. So evil Google could install arbitrary programs on your phone, but is that a bad thing, or is that a good user experience? No? Anyway, they changed everything in Android 6, and they adopted something that's very similar to what Apple has been doing for a while, which is that they ask for permissions at time of use rather than at time of install. Why is that a good thing? Well, for starters, it puts the permission request in the context of what the user's doing. When I install a mapping application, I don't immediately understand that it wants access to my location. That's not always obvious. If I install Yelp so I can get restaurant reviews, and Yelp says, I need to know where you are, you might think, oh, that's scary. They're going to track me. But when I'm like, hey, Yelp, give me a map to this restaurant, and it says, OK, where are you? Now you have the permission request in the context of its being used. Oh, I just asked Yelp to tell me where the restaurant is. It wants to, and I hit the map button. It wants to know where I am. So that's a better user experience. So Android version 6 now supports this. If your app is built against the newest API level that corresponds to Android 6, then you're required to implement this. If you're built against the older APIs, you're not required to deal with this. And one of the curious decisions they made is that every app, no matter what, has complete full access to the internet. Really? But if you want to get that, you have to implement the newest API, which means you have to request all the other permissions. So it's a carrot and a stick. I'm not sure why they made that decision. But one thing they did do is they allow the user to dig into the settings and revoke any one of these permissions for any app, even old apps. So you could install an app that says, I need your camera. And you say, well, yes, sure. And then you go turn it off again. So as a parent of a child who has a lot of games on her tablet, with Android 6, I could reach into her tablet and turn off all of the permissions that all of those stupid games request that they don't need. Curiously, CyanogenMod, which is one of the third-party Android distributions, they invented a brilliant feature that's been there for 2-3 years called Privacy Guard. Privacy Guard is a single bit, a single switch for any app, and when you turn on Privacy Guard, it will lie to the app. I want your contacts. Here they are, a list of length 0. I want your GPS location. Okay, here it is, 0,0. So CyanogenMod's approach to protecting the user's privacy was to lie to the app and give it these sort of the fake information. Google decided that they made a deliberate engineering decision that they would instead throw security exceptions. I'm not sure if I agree with that decision, but it was a deliberate decision. And the theory behind it is they want apps to actually elegantly respond to a lack of permission rather than behaving weird. CyanogenMod said, I don't care. Your location is in the middle of the Atlantic Ocean, and that's fine. Underneath Android, it's just there's a Linux kernel. And so they can have Linux kernel security mechanisms. There's a thing for Linux called SE Linux, Security Enhanced Linux, which lets you write these amazingly complicated policy files. And SE Android also lets you write amazingly complicated security policies. Mostly, these policies talk about low-level features that don't have anything to do with the apps and permissions that we were just talking about. I'm not going to spend a lot of time talking about it. But hypothetically, an organization could customize these policies. They're complicated enough that they probably never would. I mean, there are approximately 100,000 rules on a typical Android device. Where did those rules come from? They run a gigantic test suite, and they have the kernel measure all the things that were requested, and then they make sure that those are allowed, and then they ban the other ones. It's really complicated. I'm not convinced that it's the way to go. Figuring out how to do something better is probably an interesting research question. But suffice to say that the kernel has the opportunity to say no whenever control goes through the kernel. But there's a lot of things that don't necessarily go through the kernel. And so maybe you need something else. So we're good, right? Apps are isolated, permissions can be approved and denied by users, and we've gotten rid of all of these C bug patterns. No buffer overflows. So we're good, right? No. So apps in the Android world are very chatty with each other. There are several different inter-process communication layers. Binder is a kernel extension that lets two Android apps talk to each other. Intents are the Android feature that let you say, I have a PDF. Can somebody deal with PDF, please? And you launch an intent to view the PDF, and you have no idea where it's going to go. So that was a general purpose service in Android way back when, and iOS has been slowly adding some of these features more recently. And anybody could say, why, yes, I know how to deal with PDF. And then the user gets a dialog that says, here are 3 apps that say they know what to do. Anyway, so this actually creates an interesting opportunity for what are called confused deputy attacks. There was an example found by some researchers at UC Berkeley where if an app does not have permission to access your GPS location, it could send an IPC request to the mapping application, and say, hey, Maps, tell me something that would include GPS coordinates in its response. So this is an example of a classic problem in computer security called the confused deputy, where the map application is exercising a privilege on behalf of its caller in a way that leaks that privilege, and that's bad. And so the Berkeley people found a bunch of these and reported them to Google and got them fixed. So basically, any app that has a privilege and has an IPC interface could potentially leak that privilege as a confused deputy. So what about the permission dialogues? Anytime you have a user and a dialogue that says, OK, not OK, what's going to happen? Oh, OK, whatever. Users always click OK. Because they know what they want. At one point, I was visiting a friend's house, and we were going to play a movie from a DVD on her computer. And she had some kind of antivirus program on this computer. And so I put the DVD in, and the built-in player wasn't working. I said, oh, install VLC. It can do anything. She's like, okay, so she downloads it. And I've never seen the most impressive set of warning messages. At one point, it blanked the screen and had red letters. Warning, this isn't dangerous. And she's like, okay. She wasn't even reading it. She wasn't even taking the time to read it, because I said install VLC, and she doesn't. So users and security dialogues are bad. Although at least it's a modest, the install time dialogues nobody ever read ever. Runtime, time of use dialogues are slightly better, I hope. But we still have the user experience of this still needs research. We need to find a way to make fewer permission requests. And so the C thing, well, there are a ton of libraries still implemented in C. Your media decoders, once you get below a certain layer, all the graphics are implemented in C for performance. So there's a ton of C code in there. And people have, the entire browser is just WebKit, which is, hundreds of thousands of lines of C. So there's a lot of C code that's still potentially attackable. But hey, we'll just auto-update, right? Auto-update, that'll solve our problem. When we find a security bug, we'll fix it and push it out. So this is the classical thing that Android has traditionally been much worse at than iOS. So let's talk some more about the WebView widget. That's the thing you use when you want to have HTML inside any Android app. You put a WebView, and then it has various API calls, and you can have it do HTML, JavaScript, JPEGs, all that stuff. In Android 4.3 and earlier, the WebView was baked into the operating system. They couldn't remotely update it. And when you have these older phones running Android 4.3 or earlier, as WebKit security bugs have been fixed, they haven't been updated. In Android 4.4 and later, they broke WebKit out into a completely separate thing, a separate system service that's remotely installed by Google. So if you're running Android 4.4 or later, they update your WebKit, whenever they need to. Android 4.3 and earlier, Google officially gave up. They're like, our code base is way over here, and it's way over there, and we can no longer patch Android 4.3. Hey, everybody, please update. But because of the Android model, Google produces an Android software release, and then all these manufacturers, Samsung, LG, the Chinese manufacturers, they all take Google's code and ship it later. And if you say, hey, HTC, Samsung, take your Galaxy S3 that's 4 years old and please do a new software release for it, Samsung says, no, we're not working on that one, we're working on the new one. So people with these older Android phones are just walking around with huge software vulnerabilities, and you get this thing where Google points the finger at Samsung and Samsung points the finger at Google, and nobody gets fixed. So that to me is not really acceptable. But Google, never mind the WebView thing. For a lot of other services, Google said, we've got a problem. These old phones are never getting updated, and we want newer apps to have a hope of running on old phones. So Google created this Google Play Services, which is a monstrosity. It's really an operating system extension. Oh, look, the OK Google thing just noticed me, and now it's recognizing my speech and searching. That's awesome. Anyway, I said OK Google, and then it got very exciting. This happens regularly when I'm talking about them. Anyway, so in fact, they're listening in right now. Maybe they'll listen to me. So because of this, they install a ton of features as part of Google Play Services. And they've taken things that used to be part of the AOSP, the Android Open Source Project, and removed them and put them into this proprietary Google Play Services blob. And so this makes the open source people unhappy, but it makes developers happier because you can count on new features showing up in AOSP, and then you can ship an app that depends on the latest Google Play services, and then so you can have new Android features on older Android platforms. So what that's saying is, yes, you're running on an old Android, but you have APIs, newer APIs still work. So for example, you can write your app using the modern permission API, where you request permissions at runtime. And if you're on Android 6, it will request them at runtime. If you're on Android 4.3, it'll request them in advance, but at least you compile it once, and you ship it once, and it'll run. So it's API compatible. So Google is trying to make your life as a developer slightly less annoying and painful. But hey, what about all those Chinese iPhones? In China, where they at the Great Firewall, they block Google altogether, then you can't get updates from the Google Play Store, Google Play Services, all of the online things that Google provides, which means all of these no-name Chinese Android derivative phones are in a world of security hell, and there's nothing Google can do for them, which is kind of sad. So what's happening? There have been, particularly with regard to WebKit, Google in the last within the last year had a couple embarrassing moments of security vulnerabilities. And Google said, OK, fine. We are going to do monthly pushes. So if you have a Google-branded device, this is my Nexus 5X, I get every month a software update from Google, which is great. It's sort of like Microsoft's Patch Tuesday. So Google is doing the same thing, shipping patches monthly, and they're trying to twist the arms of the big manufacturers to also do monthly pushes. And some are better than others. Sad but true. So how bad are these numbers in the wild? So this data just came out yesterday, and I built this. I threw this slide together. So 4.4 and later are, call it 73% of Android phones in the wild. So that's like 73% of, call it 1 billion phones, are getting the latest security updates. It's the other 27%, 270 million phones aren't. So even though the overwhelming majority are getting these updates, the minority are so big that they are still a problem. Yay! So here's another common thing that people like to talk about for iOS versus Android, which is how good are they at keeping bad apps away from users. In the early days of Android, you could publish anything, and it was just instant. You publish your app, it's on the App Store, they ship it immediately, done. Whereas iOS could take days, weeks, and Apple's process was completely opaque. Humans were in the loop, and it was slow and it was imprecise. Sometimes Apple would say yes, sometimes Apple would say no, and nobody knew why. Google always said yes, and maybe they shouldn't have. More recently, there's convergence again. On the Google side, they have a system they built called Bouncer. They have said very, very little about Bouncer in public. Niels Provost, one of the people who engineered it, gave one talk at Stanford, he gave one talk at Berkeley, and they told him, shut up. So I emailed my friends at Stanford and Berkeley. I'm like, did you videotape it? Do you have anything? They're like, sorry. So nothing. Miller and Oberheide did a black box study where they wrote apps and threw it at this to see what would happen. And they observed the packets were coming from their app. So from this, they concluded that Google was running their app in some kind of virtual machine. And I can tell you that Google is very aggressively hiring in static analysis. If If you have a degree, you have a PhD in computer science, and you're a static analysis software person, you can get a job like that. What are all those static analysis people doing? Something to look for apps that are misbehaving. So this is, I mean, you can go and read the Miller-Oberheide blog post, but Google is moving very quickly to improve their static analysis. Apple, I don't know. I don't know what they're doing. Supposedly, now they're down to like single-digit days, and I know at least one really smart compiler buddy of mine who works for them. What is he doing? He can't tell me. So I don't know. Maybe. And importantly, both Google and Apple reserve the right to remotely uninstall any app at any time. So if it turns out that something gets through and is known to be misbehaving, they can remote uninstall it worldwide, like that. They don't use this often, but it's good that they have it. It's the ultimate. That way, if somebody discovers bad behavior, there's a fallback. All right. Authentication. Both Apple and Google are furiously innovating in this space. Apple was the first to market with a fingerprint reader. Now Google has one. Yeah, it's a little circle on the back here. And they play it. I know more. I don't know enough about Apple to really comment, but on the Google side, they're trying to, again, trade off security and usability. So most of the time, I can get into my phone just with the fingerprint reader, but not always. Sometimes it'll say, for additional security, please do your password or your pattern on the screen. Why? I don't really know. But I suspect that this is part of the post-Snowden thinking, that if you haven't used your phone in a while, or certainly if you just turned it on from its off state, then they will defensively ask for a password. So even if somebody takes a knife and cuts your finger off, in some circumstances that won't be enough for them to get in. And exactly how they chose to do that, I don't know. But they're playing a trade-off game between usability and security. Likewise, they have this smart lock idea. So this is an Android Wear watch. My watch and my phone talk to each other. And so when my phone sees my watch, it's more relaxed about security. When it doesn't see my watch, it's more vigorous about security. Likewise, you can program it to when it sees your Wi-Fi at home or when it sees the Bluetooth of your car, then your phone will change it will lower its guard a little bit. And again, much like Apple, however they hash your fingerprint is stored in a dedicated chunk of hardware. So even if you can read out all of the RAM or the flash, you won't be able to, malware is unlikely to be able to get a hold of your fingerprint. The fingerprint data lives inside. Apple calls it a secure element. I don't think Google has a public phrase for it, but it's a dedicated piece of hardware. In order to get it out, you would have to be doing things involving acid and milling off to get down to putting probes and stuff that is most people in this room would have trouble doing. Unless there's any NSA people here. Yeah. Anyway, the other big thing, and I've collaborated a little bit with some Google people on this, is Google loves this idea of federated identity. The idea of federated identity is a much bigger topic than anything to do with Android. But broadly speaking, it would be nice if I didn't have to have a username and password for every single stupid app. Doesn't that suck? So as an app author, you can ask Google to authenticate the user. And you can give the user this dialogue that says, log in with Facebook, log in with Google, log in with Twitter. And if the user clicks log in with Google, there's an API that just pops up a little thing that says, hey, random app would like to know your username. OK, cancel. No passwords involved. And that's excellent, because at that point it happens at time of use, which is better than time of install. And if the user can say yes or no, the user doesn't type a password. So we can get the user out of the habit of typing passwords all the time. That's a good thing. And you can go back later and see a list of all the apps that are allowed to authenticate through this mechanism, and you can revoke them if you want. It's reasonably well designed. And the protocols underneath it are basically OAuth and OpenID, which maybe are not as complicated as TLS and IPsec. They're still more complicated than I could possibly hope to talk about today. But they're working. This is all about trying to improve the user experience. Fewer password dialogues, fewer permission dialogues. All right. I'm about to move on and talk about advertising. So this would be a good place for people to ask me questions about Android broadly. Questions? Yes?
What would be your overall recommendation? Is Android secure enough to use?
I've been using it for years. The overall recommendation is you should use, if you're going to use Android, I would say use Google branded Android without the extra crap from a vendor. So if you get a Google Nexus device, this is a Nexus 5X, then you're getting direct software support from Google, monthly patches from Google, and you're not dealing with the manufacturer at all. Whereas if you buy any other Android device at all, then you are 6 months to a year behind Google. And that, to me, I mean, the vendors have promised they're going to get better, but it's still a problem. So I think that if you are using a Google-branded device, then you are in as good or better a position relative to Apple. That's sort of my own view on this. Yes?
What about full device encryption on Android? It's now really hot on iOS, but for Android there's not that much you can find about it, how exactly it works.
Android 5.0 added it. Android 6.0 makes it on by default.
Yes, but how exactly it works, where it stores the key and so on, it's not that much you can find about it. I'm not sure how good it is.
Yeah, I don't know. What I do know is when I used to be afraid of turning on encryption because I said, what if there's a bit error and then I lose all of my data because the encrypted file system failed? That was my big worry. But when Google in Android 6 says we're turning it on by default, I'm like, all right, they must trust it. So what I do know is that when my phone boots, it gets very early in the boot sequence and it stops and it asks me for my password, my pattern. So what that says is they're doing boot locking in some interesting way. Like long before the operating system has booted, very early in the process, they ask me for a password or PIN or whatever. And so that means that if I'm concerned about somebody physically stealing my phone and I know I'm going to be going through a sensitive place, like entering or leaving a country, I turn off the phone. If the customs agent demands that I touch it, like, okay, it's not going to work. Type okay, please give us your password. No. So they've thought that much through. I don't know how much they store. I know that there is, like I said, this trusted element that stores the fingerprint data. I don't know how much of the boot data is also in there. But the fact that they're doing this check very early suggests that the file system is truly encrypted and you need to enter this key to derive whatever master secret is used to unlock and boot the rest of the Android operating system. So again, broadly, is it better or worse than iOS? I don't know. But unlike iOS, it's actually open source, so you can go look at it. And you can see for yourself if you think it's good or bad. But suffice to say that they're working on it. The feature is there. I don't know if that makes you feel better or worse. I mean, open source means that the adversary gets to look at it too. But there are a lot of people who are really good with IDA Pro. So, an adversary trying to reverse engineer iOS to find a vulnerability, the fact that they don't have source code doesn't slow them down too much. I was waiting for Ken to chime in and say something that I'm provocative, and because here I am beating up on iOS.
No, you go right ahead.
You're the iPhone guy. Yeah, I mean, I know hardly anything about the iPhone. I mean, it's impressive that both vendors are rapidly improving. And you can definitely see a post-Snowden influence on Apple and Google. They both are upping their game in a big way. Other sort of broad questions on Android? Anyone?
So what about the vendors? If you were to go for a vendor, are there any vendors you would recommend or that you see that are really upping their game?
I don't know. I know that Samsung put a lot of effort into Knox, so Samsung Knox was a system that allowed you to partition Android into basically two internal Androids, your work and your home. And then the idea is that, let's say my employer gives me this phone and they can remotely obliterate the work side of the phone if they want to fire me. But I still have the home side. So it's sort of this partitioning. And supposedly Android 6 has adopted many of these Knox enterprise level features. I don't use them, so I don't know exactly how they work. Now BlackBerry is shipping an Android phone. And BlackBerry has traditionally been widely used in government and big business because they like the manageability. So has BlackBerry added enterprise management features to Android? I have no idea. They added a little flip-out keyboard. People seem to like that, but broadly speaking, I don't know. My worry is that I trust software people. I don't trust hardware people. Yeah. I want to know that there's a software organization that's taking care of me. And so from a security perspective, I like that Google is directly supporting the Nexus line of phones. Whereas when you get something else, then you're now getting software filtered through and patched by somebody else. And I think that that's undesirable. And I hope that eventually the vendors stop with all the stupid customization and skinning. They mostly just make it uglier and slower. Other broad questions? Yes?
What's your opinion about Google services and the information Google can grab from your smartphone, from your stuff?
So privacy issues with respect to Google. You can use Android without connecting it to Google, but that's not really using it the way it's meant to be used. In the same way that you could use an iPhone without ever connecting it to Apple, but that's not the way it's meant to be used. The online updates, the connections to your account, the connections to the cloud. So, would you rather be connected to iCloud or Google's cloud? Google's business depends on their ability to keep their cloud up. Apple has had some notable failures of the iCloud. Well, they seem to be getting better. So, whereas, Google has had some notably clunky hardware, and they seem to be getting better. So, again, they're both rapidly trying to improve. If you want an Android device that is not in any way, shape, or form connected to Google, well, there's plenty of no-name Chinese ones that you can buy for cheap. But now you're counting on some Chinese firm to support you. How does that make you feel? Or maybe you could buy this BlackBerry device and you trust this Canadian firm to support you. They're Canadian, so they're good, eh? I don't. You have to have somebody support you, especially when you is not a computer scientist, when you is somebody walking down the street who's never programmed a computer in their life, doesn't know what systems administration is. They just want to have a device that works. That means there has to be a company supporting them. So who do you want to support you? If you don't try, I use Gmail, I use Google Calendar, I use all these Google services. I've already bought in. If Google was evil, I would be in trouble. right? And if you use iCloud and iMessage and all the other Apple stuff, you've bought in. You're trusting Apple. And Apple is doing a lot of things to try to earn your trust these days. You know, like all this crazy San Bernardino iPhone stuff. Apple is trying really hard to convince you that you should trust them and that they have your back. Even in the face of a government issuing an order to make them do something, they're fighting it. So, you know, you should trust them? Maybe? Ish? I don't know. These are great questions that don't have good answers. Other general purpose Android questions before I dive into some more pointy details that I think are fun. Anyone? All right, onward. So I want to talk about Android security versus advertising. This will make sense. So we have all of this amazing information that's available in a smartphone, any smartphone. Geolocation, address book, various unique identifiers, Ethernet MAC address, IMEI number, your personal photos. And we have a long history of apps abusing your trust in them. One example was this app called Path, a social network of some kind. And they would download your entire, or upload your entire address book without asking you first. And when asked why Path didn't give the user the choice to opt in, the CEO said, "This is currently the industry best practice, and the Apple App Store guidelines don't specifically discuss contact information." This is 2012. They do now. Anyway, why would they upload all of this stuff? Because money, because advertising, because profiling. So this kind of thing is worth thinking about directly. So students in my group have done a bunch of work on Android, both in terms of adding architectural features and studying the ecosystem of the advertising world. And I'm going to tell you a little bit about these things now. So, ads. Let's start with ads. On the left is a dictionary app, which is free, and there's an advertisement at the bottom. On the right is the same dictionary app, and it costs $3 US. No advertisement. Everybody take a guess. How many installs are there for the pay version? Have a number in your head? What do you think? Shout out a number.
1%.
So give me an absolute number.
200.
200.0. Perhaps higher. Any other guesses?
10,000.
10,000. Any other guesses?
1,000?
Sorry?
1,000?
Okay, so the actual number is 100 to 500. That's what Google Play Store reports. They don't give you an exact number unless you are the vendor. How many do you think took the free version with the ads? The rest of the world. Billions! So the answer is 10 to 50 million. So 2 orders of magnitude more people install the free one than the pay one. The market has spoken. People are cheap. And they will put up with ads rather than pay $3 to make them go away. $3 is not a lot of money. And these ads are everywhere. You want to play Angry Birds and there's an ad. And oh, by the way, they use 75% of your battery. That's amazing. This was a lovely paper by some University of Washington researchers. So ads are using 3/4 of your battery budget. That's a precious resource. So to understand the mobile advertising universe, it helps to understand the web advertising universe, because it's the same exact back end. App developers host ads, and when users click on them, the app developer gets some money. So how do you do ad targeting? The more user data you have, the better you can target the app and the more money you make. Which means that advertising libraries incentivize the apps to tell them things about the user, because then they'll make more money, because the users will be more likely to click on a well-targeted ad. And of course, more user data means more permissions. So now we have a feature we call permission bloat, which is apps requesting permissions that they don't need to do anything related to their function as an app. Dictionary.com does not need to know your location. But if they have it, then they can give you better ads. And what does that do? You start having interesting debates where an antivirus company said, that's malware. And they said, no, it's not. And you have the definition of malware starts becoming blurry. We're just advertising. You're malicious. We're not malicious. This is the debate that goes on every day. This this happens all the time. And is it getting worse? Let's have a look. So we downloaded 114,000 apps from the Android's Play Store. And you can decompile any of them and look at the different things inside the APK file. 56% of our sample had at least one ad library. Some of them had as many as 8 or 9 ad libraries. So the size of the ad libraries is dwarfing the size of the application. We had 108,000 unique ad library things that we extracted, which we break down into 68 different families. Many of these are just different versions of the same library. So now let's plot them. So the x-axis are different ad libraries. The y-axis, the blue bars are number of apps, unique apps that have that ad library within them. The red bars are install count in billions of that library across all apps. I mean, this is all rough because we don't have exact install counts. We just have these 100 to 500,000 numbers. So we're just using the smaller one. But these give you a rough shape of what's going on. AdMob, which is owned by Google, has 38% of all apps. And they similarly have a large share of installs. The top 10 have 71% of installs. The top 25 have 90% of installs. A relatively small number of ad libraries have a relatively high fraction of the market. So how do you date them? We grab the sample all at once, but we want to be able to see old versus new ad libraries. So when you download an app, it has the date at which it was uploaded. That's just part of the metadata. You know when that app was uploaded to the store. So what that tells us is the ad library version in that app can't be any newer than the date on the app. So older apps give us older samples of libraries. The older apps have older versions, the newer apps have newer versions. It's not perfect, but we can work with it. So you separate the libraries out. People have done various work to map Android calls to the permissions necessary. So we can, it's more or less just grep. We're looking to find which API calls are being made by the libraries as distinct from the apps that host them. What do we find? First off, we don't care about the apps. We only care about the libraries. We don't notice if a library is being, there might be dead code in the library, maybe because they didn't have ProGuard configured correctly. So, and somebody else has ProGuard turned on, and then dead code is removed. So we're going to see slightly different versions over time. Anyway, and of course, if there's dynamically loaded code, we won't see it. So you get a graph that looks kind of like this. The x-axis is time. The y-axis is percentage of apps percentage of libraries. We're now treating each library the same. Percentage of libraries that have a given feature. So every single ad library uses the internet. I'm sure that comes as a shock to you. No. No internet, you can't get content. Well, a significant number want to vibrate at you. You have an ad. Is that annoying? Many of them are looking for unique numbers in order to be able to identify you across apps. So that could be your IMEI. They're also looking for unique numbers they can get from your Ethernet MAC address and other ways of scraping your system to look for things to profile you. Hey, let's do a wake lock so that way we can blast video at you. And of course, what does a wake lock do? It keeps the screen on, and if you keep the screen on, then you're burning a lot of power. Yay! They'll check to see if you're on Wi-Fi versus mobile. Maybe they'll drag down more data over one versus the other. A lot of them want to know where you are. And then there are permissions that we lumped into this pile that we call dangerous. So now I'm going to zoom in on those. Actually, first I'll say, when we do an install weighted version, this version is not install weighted. This is every library counts equally. When we go to an install weighted version, now basically AdMob is dominating. So this is AdMob plus a little bit of noise from the competition. Academically interesting, but perhaps less exciting to talk about. I want to talk instead about these dangerous permissions. I've rescaled the y-axis, so you'll see it only goes up to 9%. But this is PS. This is listing all the other processes that are running. Why do they want to know that? Because they can profile you based on the set of other apps that are running on your device. They want to read your web history and bookmarks. Why do they want your web history and bookmarks? To profile you, to figure out what you like and where you go. They want to get your accounts, get your Facebook ID, get your Google ID. Some of these APIs would require the user to do some clicking before they'd learn anything, but nonetheless, why is an advertisement API using anything to do with my Google ID? Why? So that way they can track you. Or they're looking at your contacts. Now we're starting to get creepy. I don't want you looking at my contacts. Or they'll even change the Wi-Fi state. You turn it off, they'll turn it on again. Download some stuff. Gross, ew. Or hey, turn on the audio and see what's going on. Hey, I heard you listening to some dubstep. Would you like to buy some dubstep tunes? Anyway. Or they'll even use the camera. Yay. So in 2013, Google decided to do some quality control. And they removed 60,000 what they called low-quality apps. And we're like, what? What did Google do? So wait a minute, we have a sample of apps from the App Store. So we looked again to see which of our sample were gone. This is sort of a censorship thing. You see it before, you see it absent later, it's gone. You can conclude that that was part of this purge. So what we noticed were that certain libraries correlated strongly with being removed. So, Everbadge, Hunt Mobile, AirPush, these libraries caused their apps to be removed. What are these libraries doing? Some of them would pop up notifications, put icons on the desktop. And notifications are supposed to be telling you, here's something you need to know. You have new mail. You have an SMS. You have a meeting in 10 minutes. Not, you are getting a discount on coffee from Starbucks. Right? That is not something that belongs in the notifications. And so Google, through some unknown process, tried to remove these low-quality apps. So again, this is this interesting thing of who's policing their app store better, Apple or Google? Well, they're both working on it. They're both trying to protect their users. All right, this was fun. Conveniently, we took our sample before the Google purge, and that let us do this extra work after it. So, here's a question. Are apps leaking sensitive data? Well, we've already shown that they're measuring things. What are they leaking? But hang on, I told you what the advertising libraries are doing. What are the hosting applications doing? Are they willingly telling things that they know to the advertising libraries? Turns out there are all these really interesting APIs that ad libraries provide to applications. So set area code, set income, set postal code, set age, set ethnicity. Set ethnicity? Most apps don't necessarily know the user's ethnicity, but maybe they can make a guess. I don't know. And so these are, if we see a call to any one of these APIs, that is a call being made by the app telling the advertising library something that it knows or infers about its user. And that's interesting. So how often are they used? Well, the top ones are these arbitrary data and keywords, where you can set key value pairs. What key values? We don't know. This was a really dumb grep kind of search, which is robust against obfuscation, but it's not real useful in telling you exactly how they're being used. But we see, 2 to 3% are setting gender, 1 to 3% are setting location, 1 to 2% are setting age. So single-digit percentages of apps are leaking things that the app knows about you to the library. That, to me, is the big takeaway from this. But this is fun. The x-axis is the install count, like how many apps are there for whom there are a given number of these API calls that leak sensitive data. So, and notice that this is a log scale. So what's going on here, what you see, is that as apps become, okay, first off, the very, very small number of install count apps are just evil. But not enough people have them that they're meaningful. But as you get more and more installs, you start leaking more and more information about the user, which is interesting. This says that when you have millions of installs, that extra percentage of revenue gain starts to be meaningful. So you're willing to compromise the user's privacy to gain additional income. Except when you are at the very, very top, you start behaving better again. So does that mean that Facebook is better behaved because they're worried about being embarrassed by leaking things? Perhaps. Or is Facebook behaving better because they already know everything about you? They don't need any help from the phone. They know your friends, they know what your likes, they already know everything. They don't need to learn any more. Yeah?
I just want to check whether I understand this graph correctly. You said that on the left there are a very low number of evil apps. But if I look at the graph, can I conclude that somewhere around the 5 million mark, the apps are actually even more evil?
So yeah, to be correct, so these are apps that have like less than 5 installs worldwide. So apps that have virtually no installs, I kind of don't care how bad they are because nobody's using them. But apps with 5 million installs, which is really 1 to 5 million because they don't tell us, apps with 5 million installs are leaking more stuff.
Per user.
Sorry?
Per install.
Yeah. So that's interesting. This to us, this graph was really a surprise.
Did you know that actually they first get few and then when they get more installed, they actually increase?
Yes.
You know what I mean? Is it, yeah.
Because if you are at the 5,000 installs level, your ad revenue, if you make $1,000 a month versus $1,100 a month, how much of a pain in the ass are you willing to engineer to get an extra $100 a month? If your time is worth anything to you, you don't care. But if you're making $10 million a month, going from 10 million to 11 million, that extra $1 million is worth it to you. This is my interpretation of this graph. That getting an extra 10% bump isn't worth it when you're making small money, but it is worth it when you're making big money. I have no idea what the actual ad revenue is for apps with 5 million installs. I'm making wild guesses. Is anybody here actually an app author? Anybody tell me what kind of revenues apps get? I have no idea. It's a mystery. Okay, so that's sort of our study of this is what's going on in the real world. Now, what do you want to do about it? How could we... So the nice part about this sort of research is I don't need any permission from Google. I don't need permission from anybody. I just download things and measure them. Lots of fun. You can crank out measurement papers pretty quickly if you want, and if you have a grad student who's good at this sort of thing. Lots of Python scripts to glue it all together. And to avoid the rate limits on the Play Store, you come from a lot of IP addresses. And anyway, it's sort of a pain, but you can do it. And 100,000 apps is small change. These days, people doing these studies tend to do 1 million apps, because why not? Anyway, let's try to fix the problem. Let's try to engineer something better. Let's try to engineer a better advertising container. So to understand how we might do that, first it's helpful to understand what kind of a security model, what's our threat model, what's going on. So since, as I said before, advertisements on apps are basically the same infrastructure as advertisements on the web. So what's our web security model? Well, we have this thing called mashup security. We've talked a little bit about web security. Early speakers today have talked about things. Broadly speaking, if you have a website and you're hosting an ad and you don't trust the ad, you stick it in an iframe. And that means that that advertisement is in a box, and assuming the web security model works, and they keep finding workarounds and they keep patching them, but an ideal iframe is like a whole separate website. It can't see the host, and the host can't see inside the box. They're just two completely separate websites that happen to be co-located on the screen. And the same origin policy, which is built into the browser, means that the outside can't look in and the inside can't look out. Now, there are some goofy exceptions to this that aren't worth getting into today, because we're talking about Android, not the web. But Android has no iframe-like mechanism. There's nothing in Android that lets you have two things sharing the screen that are separate. So we fixed that. So we built this system that let us have an app on top with a little transparent hole, and we could run the advertising layer below, showing through the hole. Android supports this notion of partially transparent windows. You can have just alpha. So you can have multi-layer Android, and it works just fine. And we had to solve a bunch of problems I'm going to tell you about. We had to deal with the layering and separation. We had to deal with passing the clicks around. We had to do some OS verifiable statements, which I'll talk about. And we wanted to build a world where the app doesn't trust the ad, and the ad doesn't trust the app, yet they can mutually work together. This was our engineering goal. So, beforehand, as I mentioned, each app is running in a separate box owned by like a Unix user, which corresponds to the developer. So here's app A, and here's app B, and they both have this ad library inside of them, linked in with the main application. And the ad library keeps its state alongside the application. So the ad library has state, the application has state. They both save it in the same bucket together. So certainly we could create a separate box with a separate Unix user. But now I have to create multiple instances of this library and keep them from stepping on each other. But I can do that. I have to deal with a bunch of really, so now I have a hard problem. I have to launch these apps, I have to launch them together, take them away together. If the user rotates the screen, I have to rotate both of them together. My student Shashi spent like 6 months making everything on this slide happen. It was just gross, ugly hacking to get all of the Android system services to treat these two things together and move them together and resize them, to everything to happen together. Gluing two apps together was not a native feature in Android. Anyway, so a lot of work went into making these mundane things happen. So now we have this user input problem. I want to make it such that the user, an evil app might generate fake clicks to the ad library to give itself revenue. Or an evil ad library might want to take over the screen or do other bad things. I want to support a mutual distrust, where the application doesn't trust the ads don't trust the application. Well, what happens when the user touches the screen? Where do I send that event? Who gets it? So our decision was that we would have the application receive the click, and if the application decided it was for the ad, the application could send the click through. But that meant we needed to have a way for the ad system to verify that the click was legitimate. So this is fun. We thought that we could have, there were two architectures we came up with. The first one was just to give it a unique ID, like a cryptographic nonce, and then you could query an operating system service and say, I saw this nonce, is it legit? The other option was to use HMAC. So we would have a system service that would use an HMAC to compute sort of a cheap signature. And it turns out it's cheaper to compute an HMAC SHA-1 than to do an OS call, which is kind of amazing. It's cheaper to do a bunch of cryptography than it is to make a context switch into the operating system and back again. That was surprising, but operating system people have been yelling and screaming about this for a long time, and the problem continues not to go away. Anyway, so the input system just HMACs everything. And the verification, as you move your finger around the screen, you're generating as many as 200 touch events per second. But you're only going to verify one of them, the one that's like finger up, that says, okay, the user stopped here and now they touched this button. So for that one verification operation, then I'll pay the cost of going through the operating system, and because I don't have the key to verify the HMAC, I have to ask an OS service to verify it for me. So that was our like surprising but remarkably efficient solution to that problem. And it turns out Android already has visibility verification. Like when I have these two layers, there's already an API call that lets me say, hey, which of my pixels are visible to the user? That's already a built-in API call. So the ad service doesn't have to trust the application to display it correctly. Whereas in stock Android, you could have an ad library and then you could never display an ad but still send click messages out. Anyway, so we built a decompiler that when you install an app, it would read the manifest, it would drop in a stub and have an external process. We did all of this work for AdMob. It's all really nice. Then we built this complicated touch event validation system. So the event system sends a stream of these signed, HMAC encrypted signed touch events to the host activity, that's the application. It then passes on the ones it cares about to the ad service. And then the ad service can talk to our authority manager. So this is the expensive call, but this doesn't happen very often. And then that can say, all right, you're good. And then you can pass it on to the ad activity. This is the original unmodified AdMob code. And this is a wrapper that we put around the AdMob code to do all the extra security features. And we're like, great, we built automatic separation, we built automatic wrapping, we're done, right? Well, AdMob is only one. How about the other 67 ad libraries? And we started thinking about this, and we're like, oh God, we have to re-engineer 67 ad libraries? That's terrible. And the other thing that we're missing is that we have this operating system service that can verify the authenticity of a click. And then we verify the click, and then we pass it on and forget about it because the ad service doesn't know what that means. This is a missed opportunity. Wouldn't it be nice if the ad service paid attention to the authenticity of the click? And in fact, if we could pass that verification outside, that's sort of like a cryptographic attestation, that something deep in the operating system vouched for the authenticity of this click. That could help prevent click fraud. So in short, we built a thing that would convert these HMACs into digital signatures signed by an internal key, and then those could be externally verified. So we could turn these into cryptographically signed statements with a key that's buried deep in the operating system. And so this was our theory. We could incentivize advertisers to want to use our APIs. Because by using our APIs, then you, the advertiser, have better authenticity of your clicks, better click fraud resistance. So we still had this challenge, though. What are we going to do for 68 ad libraries? We did all this work for AdMob, but we're not going to do it for all of them. And then the light bulb appeared over our head. And we said, all of these ads are using WebView on the inside. Every single ad is just opening a WebView. And then that WebView is downloading HTML, JavaScript, JPEGs, etc. And we said, wait a minute. We could just write one set of ad library native code such that there's no need for any ad library to have local code. The ad library can just do JavaScript. And we can provide a standardized system web ad service. We call this an ad web view. Get rid of all the native code altogether. Instead, we can even use all of that same origin policy stuff, so that way the ads can phone home to their ad service without being able to talk to the arbitrary internet, and we don't need any extra permissions. Yet we can still run them in a separate user ID, so we get both process security and web same origin policy security. That's defense in depth. We're like, this is awesome. We say, well, wait a minute, we still have some questions. Should we give them geolocation? Yes or no? Should the user have the opportunity to say yes or no? And if we're running the ads separately, does that mean we can do ad blocking? In return for giving you better click authentication, I also make it super easy for the user to just kill all ad web views, turn them into no-ops. But since I'm running them in separate processes with separate user IDs, that also means I could do power rationing. You have a certain number of millijoules of power to use per ad, and that's it. Wouldn't that be fun? Can you see advertisers stressing out about their power budget? I like that. Anyway, we built all of this code, and we're like, hey, Google, do you want any of this code? Crickets chirping. Nothing. But they hired all the students who worked on it. So, great, you're smart security people. Here, have a job. None of my former students are working on this at Google. They're all doing other things now. Anyway, what am I going to do? So how do I measure this? How do I convince you that this is... the performance cost is not really measurable. But one of the things that is measurable is memory use. So Android people really stress out about memory. Because Android was designed in a time when phones were small. So they really, really sweat bullets to make a Hello World app be small. If you write an Android app that does nothing more than print hello, and that's it, it's going to be maybe 1.5 megabytes. Very small. By the time you add a web view and the AdMob layer, now you've ballooned up to, almost 7 megabytes. plus all the memory the browser uses. So what about our system? Well, we still need the web view, assuming the application was using a web view on its own. And then we're making a whole separate activity which has another web view. And then the addmob library on top of that. And you might say, well, that's gross. You just wasted memory. Yeah, but maybe I don't need that addmob library because I'm just going to provide a standardized widget. Now the memory usage is about the same. And if my application doesn't use WebView, I end up saving a bundle here. So suffice to say that the memory usage is not that bad. And of course, modern Android phones have ridiculous amounts of memory. One of the vendors just announced 6 gigabytes in a phone. My computer doesn't have 6 gigabytes in it. Anyway. And just a quick aside. Earlier I was talking about security updates, right? Well, Android 4.3 and earlier are stuck with an older version of WebView. And Google has abandoned support. Google is not shipping security patches for Android 4.3 and earlier's WebView. And Google's public statement is, if you are shipping an app for Android 4.3 and earlier, and you're using WebView, do not use HTTP. Only use HTTPS or local content. That was Google's official advice to developers. Who's the biggest user of WebView? Advertising. Advertising is a massive user of WebView. How much advertising is encrypted? Like nothing. And advertising has all these redirects. You visit the first thing and it redirects you and it redirects you. Then they have an auction and people are bidding on you and they redirect you and they redirect you and finally ad content shows. All of this happens in the clear. So Android 4.3 and earlier, because of these WebView vulnerabilities combined with the advertising marketplace, it's a gigantic security hole. So interestingly, addmob explicitly encrypts the location field. Everything else is plain text, but the location field they encrypt, even though it's all otherwise plain text. Amazing. So to me, advertising is a big part of the problem. And advertising combined with these other security vulnerabilities is a big problem. To Google's credit, they have started pushing on the advertising ecosystem to move to HTTPS entirely. But that's a slow process because there's a lot of moving pieces. There's a lot of companies. So we have done a bunch of work. Other people have done a bunch of work. And since this isn't really an academic talk, suffice to say that there are tons of Android papers out every year, and it's a rapidly moving target. I'm telling you about work that's 3-4 years old, and you don't have to take pictures of it. You'll get all the slides. It's all good. So I have about 10 minutes left. Should I take questions on this or move on and talk about a handful of other things that I think might be interesting? Slightly other interesting topics. Okay. Let's talk about nation states attacking your phone. You know, when we have the FBI saying, hey, Apple, sign a specific piece of malware that we can install on this specific phone because we think there's a secret we care about inside, we are in a weird new world. Could this happen with Android? Well, you know, Google signs its code releases, and each other vendor has their own process. Will Samsung give in to the FBI? Will HTC give in to the FBI? I don't know. Each one has its own code signing and its own code verification process. There's also this whole other baseband processor that runs a whole other operating system. On Apple, it's running the L4 microkernel. Each Android device has a different baseband processor running a different operating system. And then there's this other ARM trust zone thing, which is an OS running underneath your OS. Are those things secure? Some recent researchers have found some exploitable vulnerabilities in trust zone, which is supposed to be the thing that you can trust, and turns out it might not be. So who knows? Encryption was optional. A user could enable it in Android 5, and it's on by default in Android 6. It's interesting to say, what can an attacker do if they pickpocket your phone and plug into the USB port? Right? Android, and I'm sure iOS is similar, if the phone is locked, they can't do anything. You have to unlock the phone, and then the user can approve. It'll say, hey, here's a computer that I've never seen before, and here's its public key. Should I allow this connection? It's actually very similar to the user interface for SSH when you connect to a machine for the first time. Here's a key fingerprint. OK, cancel. Which is something that most users would never see. Which also means that if a user is in an airport and they're going to charge their phone from that USB thing in the side of their seat, if they plug in and it just gives them power, there will be no dialogue and it's fine. If they plug in and they get this weird thing saying, do you trust this computer with this key? To most users, that would be an abnormal dialogue. And that's a good thing. And I hope that users, when faced with a really weird dialogue, will go, no, but I don't know. I do know that when the phone is locked, you can only install something that's Google signed. And the only way you're going to get there, I think, I'm not sure if you have to unlock the phone. You can always boot into this thing called recovery mode. And from recovery mode, you could install a Google signed thing. So this is, whereas like an iPhone will refuse to install an OS until the user types their PIN. So I think in this one tiny respect, iOS has a brief security advantage over Android. But, if you want to install an OS that's not signed by Google, it forces you to wipe the phone. So, yay. And also interesting, by the way, USB Type-C, the latest thing, not only does it have a cable that you can put in upside down, very exciting. So they finally caught up with Apple on that too. It also lets you charge in either direction. So now it's the question of, I can plug two phones and have one charge off the other one. And they have a whole separate UI for allowing that, which is kind of neat. Copy protection, piracy is a problem. In the talk before mine, you learned all about code obfuscation, and I think that that's an important technique. But broadly speaking, this is an open problem. How are you supposed to avoid your app being reverse engineered and redistributed? It's a moving target, right? We haven't solved the problem, not at all. There are a bunch of APIs that let you query the Play Store. So an app can, at runtime, say, have I been authorized? Did the user pay for me? But somebody who's going to go to the trouble of reverse engineering and decompiling could jam a branch around that. So now I need to put that check in hundreds of places in my code. And I don't know. Again, I can make it harder and harder, but the reverse engineering people are probably going to win. Anyway. The net result of this is most apps are moving to a freemium model. So I give the app away for free, but I charge you for in-game upgrades. If you play a game and you have the normal sword and it does some damage and I pay more money and I get a bigger sword. And that seems to be the model, that I pay for upgrades. I pay for extra things that make the game more fun. Anybody ever play Plants vs. Zombies? Oh, it's one of my favorite games. Great game. You can play it front to back. No ads, nothing. Awesome. Then there was Plants vs. Zombies 2. Playable or unplayable? I would say damn near unplayable because they tried so hard to monetize. Oh, you can easily plow through the levels if you pay money for extra features. But if you want to play the game for free, it gets really hard. I'm kind of pissed about that. Anyway, wrapping up. What is the future of Android? I don't know. Google doesn't tell me anything. Like, are they going to have Java 8 support? That would be nice. I don't know. Are they going to have, you can't install a new OS without unlocking the screen, just like Apple? I don't know. The good news, at least, is that Android has a ridiculous market share. I mean, over 1 billion people out there are walking around with Android phones. And what that means is, at least from a developer's perspective, there's incredible tool support. IntelliJ is fantastic. And if you think that Java 6 is the most old and painful language ever, you can program in Kotlin, which is this new language from the IntelliJ people. Supports Android very well. I took an Android app that I wrote and rewrote it in Kotlin, and it shrunk by 10% in terms of lines of code and in terms of the size of the final APK, which was amazing. Same app, same function, same everything. But by rewriting it and translating it to this newer language, somehow I ended up with more efficient and more compact code. It's fantastic. So even though Google is incredibly unhelpful to their developers in terms of, when are you going to do X? Nothing. I mean, okay, how do I do X in the current version? You might get some help on the chat boards or whatever. But when are you going to fix this bug? When are you going to add that feature? Nothing. Very frustrating. But, with Stack Overflow and whatnot, you can make do. And hey, Ken, is Apple any better in terms of disclosing new features prior to?
A little bit. I mean, you get the betas in advance, and you can certainly dig into this stuff, but there's a lot that they leave out until the end anyway.
And it's exactly the same with Google. All right. Any more questions? Thank you very much.